Hello, welcome to my GCSE Statistics video. We're going to look at higher paper Edexcel GCSE Statistics, the paper from June 2011. Question 1. A national newspaper printed this bar chart. 3 things why the chart is misleading. The graphs are meant to be very clear and show you about the data, so if a graph is misleading, that's very bad. And if this has actually been printed, that's even worse. Now my advice for this question is think about if you were looking at the graph, what do you think's wrong with it? If you're trying to understand what the graph's telling you, what's the problem? Well, I know what's jumping out at me is I don't have any numbers. I would at least want to see some numbers along here to tell me where the bars are going up to. If there's no numbers next to it, we have no idea. Okay, so let's just make up some crazy numbers: 10, 20, 30, 40, 50, 60. You don't have to do this in an exam, I'm just showing you what it might look like. Okay, and they might mean thousands or whatever. I'll write that in a second. The other thing that's wrong is if you're trying to read from this bar, I just drew an arrow from the middle. How do you know where it's coming from? How do you know if you're going to be drawing your line from here, or from somewhere in the middle? So the problem is that the bar is 3D. You might like drawing 3D, but it makes things much harder to read. Okay? If we've got a bar that's 2D, we know exactly where it's up to. If we make it 3D, it's much harder to know what's going on. Third point that might jump out at you is, what on earth is this gap all about? Why would you have a gap in your bar? Have you ever seen a set of axes where it does this at the bottom? Basically scrunched up. Well, I guess another way you could draw that is a gap. And it means that you might be on, say, 1 here, and then you jump up to 10 before going 11, 12, etc. So there's a gap. Okay, you might be going nicely along, I don't know, 1, 2, big gap, 107. Now because there's no numbers here, and because there's a gap, we've no idea what's been missed out. It might have been up to 70, and then instead of going to 80, jump to 150. It's just a made up number, and then carried on like that. This is actually called a broken bar. Okay? If you write broken bar in your exam, the examiner is going to know what you're talking about. It's a bad thing to have a broken bar. So the 3 points that we've spoken about, let's just write down here now. Number 1 was that there was no scale. You don't have to write essays in these exams, okay? Just explain in as few words as you can. No scale, 3D, and the third point is that there's a broken bar. All of these things make it hard to understand. 8 breeds of dogs are chosen at random. Okay, now let's look at what is represented. We have mean weights, so we have mean weight represented by X, okay, and that's in kilograms. Sorry about that box, a little bit dodgy. Okay, so weight is X. And we also have mean life expectancy. That means how long do you expect the dog to live for? Bit of a morbid thing to think about, but some people do think about that, I'm afraid. Okay, so life expectancy, and that is Y. Okay, so we've got our X data and our Y data. Now I'm not going to try and attempt to read out all these breeds of dogs. I'm not very good with dogs. Okay, I know a couple, but I'm no expert. So we're going to see what the question wants us to actually do. We've got a scatter graph. and usually they'll plot all the points apart from one which you put in yourself. So let's see what's happened. Plot information for Vizsla, that's how you say, Vizsla dogs, to complete the scatter diagram. Okay, so that implies that every other dog, all of these guys, have been put onto scatter graph apart from the Vizsla dog, who's got a mean weight of 26 and a life expectancy of 12.5. So we are going to have to put this data on ourselves. So we're going to look for 26 on the x-axis, because remember it's x and y, and there is a label to remind you that it's mean weight. So let's figure out the scale here. We're on 25 and we've got 5 bars to get to 30. So it's 25, 26, 27, 28, 29, 30. Always check your scale. So this one is 26. Okay, getting it like that. Right. 12.5, sorry, not 20.5. So here's 12, here's 13. Guess what? 12.5 is in the middle. 12.5. Now we're going to go across from there. And where they meet, that's where your cross is going to go. So let's mark it in. Perfect. Okay, that's going to get you a mark. Part B, we've got on next page here. Describe and interpret the correlation shown. So before I go back to the graph, let's talk about correlation. Correlation tells you how things are related to each other. Okay, so what we're talking about is data about two things that are measured, one going across horizontal, one going up vertical, and we're going to just put some crosses to show where our points are, and you've just seen some crosses like that. Now, if our points are in a pattern like this, that actually means that this one's increasing, this one's increasing, you see? So we always read these left to right. So as you're going from left to right, cross up, get diagonal line upwards, okay? And that is called positive correlation. If, on the other hand, your crosses were going down in a pattern, like this, as you go from left to right, you're actually going downwards. Okay, so this gives a downward slope, which is negative correlation. Let's go back to our previous graph and see which one we're talking about. Can you see which way your crosses are going? Going this way. Okay, they're definitely going down as we go across. Don't try and go from right to left, that's not how maths works. We're counting up 0, 5, 10, etc. Okay, so we're going left to right, we're going that way, and all we check is the other data going up or is the other data going down? In this case, it's going down, so it's negative. So we can answer that it's negative correlation, and what we'll see in a minute is that we're going to get a line something like this. But what does that mean in terms of our data? Okay, that's what we have to analyze. And that's why it said interpret. So interpret means, in real life, what does that mean is going on? So in this case, we're talking about mean weight and mean life expectancy. Now, as the mean weight goes up, life expectancy is going down. Okay, so the bigger a dog, the less likely it is to live longer, is the interpretation of what is going on. So you can say that many different ways. As the weight increases and life expectancy decreases, bigger dogs don't live as long as smaller dogs, something like that. I wouldn't use bigger and smaller because it has to be to do with the weight. You could have a small, heavy dog. Anyway, that's another story. So, let's put that into words. Negative correlation will get you 1 of the 2 marks. Okay, and then we have to interpret. So negative correlation, and what did we say? As the weight of dog increases, its life expectancy decreases, or you can say it in any of the ways that we talked about. Expectancy decreases, and I would just put, to cover my back, on average, because you could get a hero dog who was quite big but lived for ages. Okay, so on average, I'll just cover our backs for that one. Right, moving on. These 8 breeds of dogs have a mean, which we represent in statistics as x bar. That's how you say it. X with a line on the top is x bar of 34.1, and a mean life expectancy y bar of 11.2. Plot the mean point x bar y bar. Not too difficult. 34.1 at 11.2. Can we remember that? 34.1 at 11.2. Try my best. Right down here. 34.1 at 11.2. That's right. So the 34.1 was the weight, because that was x. X goes across, y goes up. So 34.1 is going to be just after 34, which is here. So we're going to go up here somewhere. Okay. And 11.2, this is going up in 0.2, so you can always check yourself. 11.2, 11.4, 11.6, 11.8, 12. So we go across from 11.2. Okay, and I'll do it in red again so you can see it nice and clearly. That is your average point, x bar, y bar. It should be in the middle of all the crosses that were already there. It's the definition of average. Now the next part of that question, if you saw it, said draw a line of best fit through the mean point. Okay, going through the average point is a very good way to draw a line of best fit. I did a highlighted line before to give you a rough idea of where it might be, but now we've got to draw a proper one in with your ruler as a straight line. Okay, and what we're going to do is we're going to try and be in the middle of all the points, but also go through this special point x bar, y bar. Okay, so let's give it a go. It was pretty close before, to be fair, with my guess. Now can you see what I've done? I've gone through the middle of that line, but I've also been careful to make sure that there's about the same number of crosses above the line as below. So let's check. 1, 2, 3 below, 1, 2, 3 above, and I actually managed to go through 3 of the points, including the mean. Not bad at all. Okay, let's see what we're going to be asked next. Dog owner wants to predict the life expectancy of his border terrier. Border terrier has a mean weight of 6.5 kilograms. So let's go back to our graph and see what's happening there. So 6.5 on our graph is going to be between 6 and 7, so it's here. So if we were going to try and estimate, we'd be coming up here at 6.5 and then reading off the line. Okay, now this is actually quite a tricky question, because you might think, well, what's wrong with that? It's going to be around 15.5. Well, I'll tell you what's wrong with that. What's wrong with that is our data that we started with, the lowest point was here, the highest point was here. So at best, we know what's going on between that point and this point. Okay. So let me just try and highlight that area to show you where we think we might know what's going on. We might not even know what's going on there, to be honest, but there you go. So where it is. Okay. So we reckon we know what's going on in this area. Okay. Now the point that we're looking at is outside of that area. So we're going beyond the points that we know about and going outside to try and guess. That's got a special name when you go outside of your points to try and estimate. Okay, and it's called extrapolation. So what we are actually doing is extrapolating. If you want, you could just say that it's outside the data set. That's probably the simplest way to put it. If you like your posh maths words, what we're doing is extrapolating. So it is outside our data set. Now it's only 1 mark, so that will do. Moving on to question 3. So we've got a table of information. So let's scroll down to see what it's all about. About what full-time first degree graduates did after completing their courses in 2002. So they've done their graduate degree and we want to know what they've done after. So this table shows the destinations of people that did full first-time degrees in 2002 when they finished. And this is apparently from a DirectGov website or the government website. Okay. So there's a lot of information here. So it's telling us about if they've gone into employment or not in the UK. It's telling us if they've gone for overseas employment, if they're still in education, or if they haven't managed to get a job or any education, aka unemployed. So let's see what we're going to be asked about this data. For the graduates who studied in the West Midlands, write down the percentage who are unemployed. This is a very simple case of just reading off a table. West Midlands unemployed. So we go to West Midlands, let's go for a highlighter here, and we go to unemployed. Okay, so we go down from unemployed, across from West Midlands, and we get to 7.1. So 7.1 is our answer. Nice and easy. So let's just write that one in. 7.1 is our answer. Okay. Right, for the graduates who studied in the South East area, the percent who went into permanent UK employment is twice the percent that went into temporary UK employment. You can always read questions twice if you don't follow them the first time. Twice the percent that went into temporary UK employment. So let's see where it means in the graph here. So it's referring to southeast area, 42 and 21. Yeah, 21 doubled is 42. One other area of study has this ratio of permanent to temporary UK employment. So what it means by this ratio is one is double the other. And the simplest case of one being double the other is if you've got 2 being double 1. Okay, and can you see that 42 to 21 is the same ratio? So all we want to know is another place where it's double here to here. And if you want to be precise, permanent to temporary. Okay, so permanent is double temporary. So we just analyse these numbers, and guess what? You've got a calculator in this exam, so even if you're not the best at this arithmetic, you can use your calculator. Okay, you could have done 42 divided by 2, see if you get 21. So just have a look through. Does 19 look like half of 45, or does 45 look like double 19? Same question. Nope, doesn't to me, so I'm not going to check that. 40.2 halved is 20.1, so nope. 38.9 halved is not 19.1. 42.2 halved, I think, is 21.1. And you can always check that on your calculator by doing 42.2, half it, divide it by 2, and you get 21.1. So we know the answer there is the West Midlands. That gets you an extra mark. Okay, nice and easy reading off tables there. Moving on to part C. For graduates who studied in London, work out the total percent who went into some type of employment. So we're looking at those who studied in London. So we scroll down to London. Here, total percent, let's remind ourselves, who went into some type of employment. So it doesn't matter if they were employed overseas or employed in the UK. Okay, and it doesn't matter if they were permanent or temporary. The only ones we actually don't want are if they continued education, because that's not employment, or if they were unemployed. So we're going to add up the permanent, temporary and the overseas to get our answer. So let's just circle the ones that we're going to add up, and we'll do it in red. So we're going to add up 40.2, sorry for covering that up, 19.5 and 1.2. Just play it safe, use your calculator, there's no point trying to be a hero. Okay, and when we add those up on our calculator, we get 60.9%. So that is your answer for 2 marks, 60.9%. Part D. For graduates who studied in the UK, work out the total percentage represented in the table. So let's look back at the table and see what's going on. Area of study, UK. Okay, and we've got information on people in permanent, temporary, overseas employment, or continued education, or unemployed. So let's highlight the entries for area of study UK, and let's add up the percents that I've just highlighted there. So on your calculator, it's not worth risking it and trying to do it in your head. 42.8 plus 20.1 plus 2.1 plus 19.8 plus 6.8 on your calculator, and you get 91.6. So your answer there is 91.6. And you might be a bit surprised about why that isn't 100%. Okay, 91.6. Now, if we think about what's going on, we're thinking about the destinations of these graduates. And these are the only possible destinations for them. So we need to think about why it's not 100%. So let's read the question that's just been asked. The information in the table is gathered by means of a questionnaire given to a full-time first degree students graduating in 2002. So imagine these 200 students, or however many there were, being given a questionnaire and they were asked to fill it in. Okay, and you're wondering why you've only got 91.6% of the people you asked. Well, some people might not have bothered answering it or giving it back to you. Okay, they might not have replied and given the information. Okay, some may not have replied. Stroke being asked. Okay, so that's our question 3 done. And let's move on to the next one, question 4. Some people think that drinking cocoa before bedtime may help to reduce blood pressure. A university student is going to research this. So when you research something, you want to know what you're investigating. If you want to find out something, you've got to have a good idea about what it is you might want to find out or prove. And that is the word we use for that is hypothesis. Okay, so you might hypothesize that you're going to do really well in your statistics exam. It's your prediction, it's what you think is going to happen. It's something that you can compare against real data and see if it's true or not. So we need a prediction, something that we can investigate, look into, find out if it's right or wrong. Okay, so we could say that we think that drinking coca before bed, just use the same words they've used, before bedtime, reduces blood pressure. So to make a hypothesis, if it's already given you a lot of information that you want to find out about, you just have to put it into a sentence, a prediction. So we're predicting that drinking coca before bedtime reduces blood pressure. Next part, the student decides to collect information from students at his university. The student decides to use a sample, not a census. So census is where you're going to ask everybody. Sample is like it suggests, you just ask a sample of people, some of them. Okay, and there's many different ways that you can decide to do a sample. So, 2 reasons why it's better to ask not everyone than it is to ask everybody. Okay, well, one reason would be that it's easier to do, isn't it? It's easier and quicker. Easier and quicker. Oh dear. Another reason might be that it's more convenient, less data to analyse, more cost effective, lots of different reasons. Okay, it's cheaper to just ask less people than it is to go and ask everybody if you had to produce questionnaires and things to ask. Part C, describe a sampling frame that the students could use. Right, so what sampling frame means is where they're going to get the information from to pick their sample of students. So think about how you're going to pick a selection of students from the whole population of students that are at the university. You would want a list of all students, wouldn't you? Okay, so if you have a list of all students, then you can pick the ones that you want with whichever method you choose. So a list of all students at the university. Okay, get you 1 mark. There are more females than males at this university. The student wants his sample to show this. So write down the name of the sampling method he should use. Okay, well, the one that's fair, the sampling method that's fair and representative is stratified sampling. Okay, so that's just a definition that you need to learn. A quick example of stratified, if you have 100 male and female, and if 60 were male and 40 were female, and you wanted to pick 10, how many male and female would you pick? Would you pick 5 of each? You could do, but if you did, that wouldn't be a stratified sample. If you had a stratified sample, you'd have to make it fair so that the number you pick in your sample represents how many are in the whole population. There's more males, there's 60 for 100, so let's put it 6 for 10. Less females, 40 for 100, so let's go 4. That would be stratified. Quick explanation for you. Control groups are extremely important when you're doing an investigation, because otherwise scientists or mathematicians might say to you, How do you know that what you were investigating caused that change? There might be a psychological effect from having the cocoa. So need to test people with and without to see in the same conditions to see if it is going to work or not. Okay, next one. Question 5. A holiday in which people can visit 2 cities is called a two-centre holiday. A travel company offers 4 two-centre holidays. The two-way table shows the number of these holidays booked in 2010. Complete the two-way table. Okay, so all we've got to fill in ourselves is the totals. So this one's quite easy. The totals, you have to go across in a row to get the total here, and in a column to get the total here. Okay, so let's go for the row one first, and we're going to be going to Venice and Rome. So let's add it, 24 and 26. You might not even need a calculator for that one. 50, and let's add it, Venice and Rome from Paris, which is going to be 44. And the total coming down, like we talked about, is going to be 56. Coming down from Rome is going to be 38. And these two totals should be the same. So let's just check that. 56 add 38 is going to give you 94. And guess what? 50 plus 44 is 94. So you can be quite confident that you've got those 2 marks. Part B, which of the 2 centre holidays did most people choose? Okay, so let's read the info again if you ever need a recap. A holiday in which people can visit 2 cities is called a 2 centre holiday. 4 2 centre holidays. Okay, so I was actually reading it slightly wrong before. This one is going to Geneva and Venice. This one is going to Geneva and Rome. You see? This one, Paris and Venice. Sorry if I misled you a little bit there. This one, Paris and Rome. Okay, so that's 4 different ones. Which of the 2 centre holidays did most people choose? Well, which one has got the most people in it? It's going to be Paris and Venice because it's got 32. Okay, so Paris, Venice. Well, because most people have chosen it is surely the answer. More people. So 32 chose it. More than the others, okay? So highest one. Right, moving on. A person taking one of these holidays is chosen at random. What is the probability this person visited Rome and Geneva? Let's go back to our diagram and let's see where Rome and Geneva is. It's here. So 26 people went to Rome and Geneva. So to get a probability, you want to know out of what total. So it's 26 out of the total number of people, which is 94. So 26 over 94. If you want to put that into your calculator, it will simplify it for you. You might as well make the use of having your calculator, and you can leave that as either 27.7% or as a fraction it's going to be 13 over 47. I prefer a fraction because it's more accurate. Given that this person visited Venice, given that probability, quite challenging. Given that this person visited Venice, okay, the person visited Randon definitely went to Venice, so we can forget the rest of the diagram. We can forget about the possibility that they went to Rome, Geneva, that they went to Rome and Paris, because we know they went to Venice. Okay? Work out the probability they also visited Paris. So, if they went to Venice, they could have either gone to Geneva, which is 24 of them, or Paris, which is 32 of them. Now the total that went to Venice is 56, so it's going to be out of 56 because they're the only ones we care about. Given they went to Venice, we know they went to Venice. And how many went to Paris? Well, 32. So it's 32 out of 56. And again, you can put that into your calculator and it will simplify down to, or you could do it in your head, 4 over 7. There's your answer for 2 marks there. Okay. Moving on. Question 6. The town council wants to get information about local people's use of recycling facilities. 2 methods of collecting information have been suggested. Method 1. So let's see what the first method's all about. Ask people who are using recycling facilities at a local supermarket. Or 2. Send a questionnaire to all council taxpayers. Which is more likely to give the most reliable results? So let's get a picture of what's going on here. So what we're doing is we want to know about general people, if they use recycling or not. So what's method 1 saying? It says go to a place where people go to recycle and ask them there. Well, that's not very fair, because the only people that you're going to be asking are the ones that have gone there to do their recycling. So if you imagine this is a recycling bit, and you've got, back in the day when you had to do your own, you've got people stood here putting their bottles in and doing their recycling, and then someone comes along and they're like, hey guys, what do you think about recycling? Do you use your recycling facilities? They're going to be like, well, yeah, obviously, because we're here. So that isn't very good, is it? Second method, well, you've got your council taxpayers all at home, might be doing their own thing. Some might be on the Xbox, some might be out playing football, some might be down a recycling centre doing some recycling. Whatever these people are into, they're going to get, in method 2, a survey through the post. Okay, so method 2, because method 1 is biased, because of what we just talked about, those people obviously use recycling places, recycling facilities, because they are already there. It's just not fair at all. Already there. Too much writing in these statistics exams. Okay. One question on the questionnaire is, in what ways do you use the council's recycling facilities? This is not a good question. It's telling you it's not a good question. Write down one reason why. So my tip for you on this one is imagine that you had to answer it yourself. Okay? Well, there's no real options to put your answer, is there? What would make it much easier is if it told you some ideas and gave you some tick boxes. Instead, you've got to think for yourself and write down what you do. Okay? So it's not a good question because it's too open, and if you have an open question, loads of people could write down loads of different stuff, and then you've got to analyse it all. If you had tick boxes, then it's easier to analyse because there's only going to be a select few answers that you need to think about. Okay, so no tick boxes, they would be better if you had tick boxes. Okay. Part C. Council wants to find out how many times per month people use recycling facilities at the supermarket. Suggest a suitable question they could put on their questionnaire. So it has to do with per month. So, how often do you use recycling at supermarket? Should have written at properly, really. Per month. You need that in there. Okay, well we just said the other questionnaire was bad because it didn't have tick boxes. So we better put some tick boxes in. Your tick boxes have to be exhaustive. That means that they have to cover all possibilities that could happen. So think of all possibilities. Okay, people could never use it. 0. Okay, no times. People could use it, I don't know, 1 to 3 times. People could use it 4 to 6 times. People could use it, I'm just making up numbers here, 7 to 10 times, and you might want to leave it there, but you can't, because what if they did even more than 10? So 11 plus times. And I would like to see an on average there, so that people don't get too picky. Okay, on average, how often do you use your recycling facility for the supermarket per month? None, 1 to 3 times, etc. Do the job. Question 7. In a New Year sale, a shoe shop reduces the prices of pairs of shoes. The number of pairs of shoes sold during the first of 15 days of the sale were, well, we've got all numbers. For the number of pairs of shoes sold in New Year's Eve sale, find the median. Median means the middle number. Okay? You need to learn that one. Median is middle number. Now, in order to find the middle of some numbers, they have to be in order first. So the first thing I would do if I was you is I would write out these numbers in order. Make sure you get them all. So look for smallest one I can see 60. If you leave a bit of a gap, you can always add them in if you miss them. Next biggest I can see is 78. I can see it twice. 78, 78. Then I can see 79. Then I can see, you get the idea, don't you? I'm leaving a little bit of a gap on purpose. 82, 84. Make sure you cross them off because you don't want to count them twice or miss any out. 86, 88, 89. 91, 94, 97, 99, 100. So we've got our numbers in order, which means that they are much easier to deal with now. To find the middle number, I like the old school technique of crossing out. So 60, we're going to go to the middle, from each end, one at a time. trying to get into the middle of our data, and we find that we've got 2 numbers left. Okay, so you want to find the middle of those 2 numbers, or the mean of those 2 numbers. The middle of 86 and 88 is an easy one, but just in case it was harder, if you do 86 add 88, divide it by 2, you'll get the middle, and that will work for any 2 numbers, and we're going to get 87. Find the lower quartile and the upper quartile. Okay, so lower quartile, LQ, is the first quarter, in the first quarter of data. What we do is we cut our data in half here, where the median was. Okay, do end to median. And then we've got 2 halves of data. So let me highlight the first half. First half is coming up to here. And I'll highlight the second half in a minute. So our lower quarter is in that first half of the data. And the quarter is a half of a half. So what this question is asking us to do is to just look at these highlighted numbers, find the middle of those. Okay, so let's cross out one at a time. And this time we've got a proper definite middle of 79, lower quarter 79, and upper quarter, or upper quartile, okay, is in the top half of your data, and it's halfway through the top half. So let's highlight our top half, and I know it's a bit like year 7, but I do like this method to just cross until you get to the middle. If you want, you can figure out how many there are, and so how many you need to count in to get to the middle. It's up to you. If there were more numbers, I might do that, but that's fine. Okay. The box plot shows information about number of pairs of shoes when there's no sale on. So that's no sale there. Same diagram, draw a box plot for the New Year's sale. So it's been building us up to this question. We've got all the info we need, the lower quarter, upper quarter, and why not, let's colour code, and the median. We also need the lowest and the biggest, but we'll do that in a second. Let's put the median on first at 87. 80, 1, 2, each little line is 1, 2, 3, 4, 5, 6, 7, 87. Now let's draw a line here for our median. Okay, M for median. Let's use the colour code still. We did our lower quartile in green, 79. So 1 off 80. There it is. 79, lower quartile. We did our upper quartile in purple, 94. 91, 2, 3, 4. So upper quartile. Okay, and hopefully you know what box plot looks like. If you don't, there's one just above where we're drawing right now. No, you don't need that bit. Here. So this is the min, the max. Lower quartile, upper quartile, median. So let's make this into our box. Okay, and let's go and find out back from before what the lowest number was. The lowest number is 60. That's our minimum. Okay, let's draw it in. You would be using a ruler, having it nice and neat, and maximum was 100. Okay, so we go to 100 here. Job done. Part C. So, compare the distributions shown by the box plots and comment on how the New Year's sale affected the number of pairs of shoes sold. Now, can you see that the sale one has moved this way in the whole? Well, that means that the number of pairs of shoes sold has increased. So spread, or more precisely the interquartile range, is bigger for no sale than for sale. Okay, that much bigger. That's another thing that we can write. We can also write that the median has increased. Okay, we can see that it's moved from here to here. And we can also comment on skewness. Now, you can see skewness from box plots, because when you have a box plot, okay, that might be a normal one, this line in the middle could be anywhere in here. Now, if it's close to this side, that's positive skew. If it's close to this side, it's negative skew. No, it's not going to be a P, it's a backwards P or a B. Okay, so that's negative skew. If it's in the middle, that's around the middle, then it's no skew or symmetrical. Okay. So let's put all those things that we've talked about into words. If you want, you can use bullet points, okay? Keep it nice and precise. So, median increased from non-sale to sale. IQR decreased, so people were more consistent from non-sale to sale. We also talked about skewness. So non-sale had negative skew. And sale had no skew or symmetrical. And finally, we want to talk about how this affected the number of sales. So we've compared distributions with 3 points. For our last mark, let's just say what we said, that the number of sales has increased. Question 8. Market research company is going to take a national poll. Keyword: national poll means it's going to be a poll for the whole country. That's a lot of people. They want to find out what people think about the performance of different makes of new cars. The company thinks about using a telephone poll. They would choose 10 towns at random. They would choose 100 telephone numbers at random from each town's phone book. So that's 10 towns, 100 phone numbers from each town. 10 times 100 is going to give you 100 different numbers to ring. The people answering the phone would form the sample. Okay, so it's a lot of information to take in, and it is very helpful if you highlight to remember what's going on. So we want to get a good idea from a whole country, a bit of market research, find out what people think about the performance of different new cars. Okay, so our plan so far is from a whole country to ring up, just 10 towns, wherever they are at random. Now there's a lot of towns in the UK, so 10 towns isn't that many. And there's a lot of people that live in the UK. And 1,000 is not much out of millions. Okay? So it's a very relatively small number. So I'd say no, the sample is not satisfactory. And there's a couple of reasons. The sample is too small to be representative. We've only picked 10 towns. What about the people who don't live in those towns? We're not hearing anything from them. Thousand people. And also, these days not everybody has landline telephone numbers. So there's a bias there, okay? Because what about the people who just use mobile phones or don't have any phones? Only asking people with phones. Okay? With house phones. For 2 marks, you'd need 2 of those points. Moving on. There are 10,000 names in the phone book, for each of these towns. 10,000 names in the phone book of one of the towns. Describe how the company could take the random sample of 100 people from the book. Now at the minute we've just got long phone numbers, which aren't very nice to deal with. Order, we would number the telephone numbers, and if you have Microsoft Excel and all your phone numbers in there, this is a very simple job. Okay, in this day and age you would hope that's what you've got. From 1 to 10,000. Then randomly pick using a random number generator, and they have that on Excel as well. We could show off and put on Microsoft Excel. On Excel. And randomly pick using random number generator on Excel to select phone numbers that correspond to these numbers. You could word it slightly differently. Have we said that we're going to pick 100 numbers? Randomly pick 100 numbers using random number generator. Okay, job done. Moving on to part C, so let's see what we've got going on here. The company finally decides to collect information either using face-to-face interviews, so talking one-on-one, person to person, or questionnaire. Write down what the company needs to consider when choosing between the two. So they've not decided which one yet, but they know that they're either going to do face-to-face interviews with people and get information from them firsthand, or they're going to hand out questionnaires to people and try and get them back. 2 options. Option 1, option 2. Okay, so we need to talk about each one, say which is better. So there's going to be good points and bad points for each, and this star means that we need to explain it in a paragraph of writing, really. And this question is for 3 marks, so we need to make at least 3 comparisons. So, face-to-face interviews. May be more expensive because you've got to employ people to go out and speak to everyone, and it will take longer. And take longer than questionnaires. And there's some things to consider when looking at face-to-face. People might be embarrassed if they're being asked questions face-to-face, then you might not want to say what you really think. But if it's just writing it down on a questionnaire and no one's going to know it was you, it's a lot easier to put anything that you want, what you really think. To face-to-face. And a disadvantage of questionnaires, people might not fill in all questionnaires. Okay, so they might leave gaps, or they might not answer all the questions, or they might not bother at all. With questionnaire, people may miss out questions. So we've put quite a lot of points down there, and that should get us a 3 marks for the question. Moving on to question 9. There were 64 tsunamis, and it tells you what they are. They are tidal waves between the years 2000 and 2009. The table gives information about the maximum wave height in meters of these tsunamis, and it tells you how many you had. So let me just show you a quick example. The third one down here is talking about between 0.5, half a meter, and 1 meter. H is just standing for the height, so it's saying that the height is between half a meter and 1 meter. And the frequency tells you how many. And that means we've got 6 cases where the waves were between half a meter and 1 whole meter. Okay, so imagine the waves coming up that high. Okay, and there's 6 of them. We don't know where the heights were, but we usually assume that they are evenly spaced out. Anyway, we don't know 100% for sure. Work out the class interval. These are class intervals where you've got the data grouped. So what we just looked at between 0.5 and 1 is an interval. Okay, and we want the interval that contains the median. Remember, median is standing for the number in the middle when they're in order. Well, guess what? These categories are already in order for us. And we know how many in each group. Now we know there's 64 tsunamis altogether. So if we added up these frequencies how many, we would have 64 in total. Now what's the middle of 64? Well, that's 64 divided by 2. The middle is going to be the 32nd number. Okay. Now if we had all our numbers as they were to start with, just normal numbers, we could count up and get the 32nd number. Now we don't have that, I'm afraid. All we have is that there's 26 in the first group, then there's 8, then there's 6, etc. But what we can do is we can think how many we had at the start of a group and how many at the end. Okay? So once we've got to the end of this group, aka everything below 0.2, we've counted 26 waves. When we get to everything up to 0.5, we're going to include all of the first group and all of the next group. So that's going to take us up to 26 add 8, which is 34. Now remember that we said that we want the 32nd number. Well, 32 is between 26 and 34. So we know for definite that it's going to be in this second group. Okay, so the class interval is between 0.2 and 0.5. And that is your answer. Okay, you don't know exactly whereabouts, but you know it's in there, which is what you're asked for. If you go on to do A level, they might ask you to estimate exactly where it is. It's a method called interpolation. Okay, question B. Calculate the estimate for the mean wave height of the tsunamis. Give your answer to one decimal place. You may use the blank columns in the table to help. Now, do you remember at the start we had the formulas for the mean? And I told you we've seen the mean before and we know what the mean is talking about. For the mean average, you add up all your numbers, divide by how many there are. But if you want to refer to your formula that we were given at the start, let's just shoot back up there. It says sum of f times x over the sum of f. Okay, and I'm going to try and give you a bit of understanding of what that means as well. Now, we usually use f for frequency, so it's the first letter. Okay, and we usually use x as the things we're talking about, the things we're adding up. Now, in our case, x, the things that we're going to add up is to do with the h. But remember that I said for each of these intervals, we do not know exactly where our numbers are. All we know is that between 0 and 0.2 there are 26 numbers. So if you know you've got numbers between 0 and 0.2, if we assume they're all around here somewhere, the best estimate that you could give, and remember the question B only said estimate, is bang in the middle. So we're going to assume, instead of thinking about how spread out they were, that they're all here in 0.1. So we're assuming that 0.1 is the average of all these numbers. So what we're going to do is we're going to use x to represent the middle of each category. So the middle of 0 and 0.2 is 0.1. The middle of 0.2 and 0.5, you can do it on your calculator, add them up, divide by 2, is 0.35. The middle of 0.5 and 1 is 0.75. Middle of 1 and 3 is 2. Don't worry about the 0.0. Middle of 3 and 5 is 4. Middle of 5 and 10 is 7.5 or 7.5. Middle of 10 and 30 is 20. The middle of 30 and 60 is 45. So these are all our x's. Now remember what the formula said? The sum of f times x over the sum of f. Let's think about what the mean means and why we're doing that. The mean means add up all your numbers. Now we've just said that we're going to estimate that there's 26 values of 0.1. If we want to add up 26 lots of 0.1, that's 26 times 0.1, which is 2.6, but you can do that on your calculator also. So what we're doing is we're timesing how many we've got by x, and in this case our x is just an estimate for the midpoint, okay, for the average in that group. So we're going to do that for each one, and the little trick I always show is just do little multipliers along here, and if we actually added up all these numbers after we get them, that is going to be the sum of f times x, which is this part. And the sum of f is just how many. Remember the mean? Divide by how many you've got. That bit, 64. So let's crack on. On our calculator, 8 times 0.35 is going to give you 2.8. 6 times 0.75 is going to give you 4.5. 6 times 2, we can do that ourselves, it's 12. 5 times 4, we can do that ourselves as well, it's 20. 8 times 7.5, you might want to do it yourself or on your calculator. Either way, it's 60. 3 times 20 is also 60. 2 times 45 is 90. Let's add up all these numbers to get what we talked about, the sum of f times x. So adding up on our calculator, 2.6, add 2.8, add 4.5, add 12, add 20, add 20, add 60, add 60, add 90 is going to give us 271.9. Okay, so write that in, 271.9. Right, so that's this top part of our formula, and the bottom part is 64. So we're going to write down, show our examiner we know what we're doing, the sum of f times x over the sum of f, and it's going to be 271.9 over 64, and we're going to give it to one decimal place, so do this on your calculator, and you get 4.24843375. We want to give our answer to one decimal place, so we want to round. Okay, one decimal place, look next door, it's 4, so your answer is going to be 4.2, and if you want to give your units, it's going to be meters. Okay, so that is part B done. Moving on to question 10. We've got some pie charts. Comparative pie charts to be precise. So can you see that in 1991 we've got more data because it's bigger, okay, than in 2005 where it's smaller. Its radius is bigger and hence its area is bigger, so that means that there's more data in 1991. What's happened to the total number of women who married in 2005 compared to the total number in 1991? So we've gone from a large bar chart to a smaller bar chart, and what we just talked about is that it's gone smaller, so there's less people there, just less data. Okay, so number has decreased, and the reason is bar chart, not bar chart, the pie chart is smaller. Pie chart area is smaller. Okay. Next one, part B. Write down the age group. Write down means you're going to be able to solve it straight away with the greatest distance, the greatest decrease from 1991 to 2005. So which area has got from a bigger area to a smaller area? Okay, and can you see that it's this light grey shaded one? It used to be quite big, and then it's gone to pretty small. So it's gone from that area to this area, and if we look at the key, it's here for 20 to 24 year olds. Okay, so that is your answer. For 30 to 49 group, so let's have a look at the 30 to 49 group here. Describe how the number of women who married changed in 2005 compared to 1991. So what's happened is the area has increased, hasn't it? Okay, we did have this area, and then it's gone to this whole area. So there's actually more women getting married between the ages of 30 and 49 in 2005 than there was in 1991, because it's a bigger area. Okay, the number of women has increased because the corresponding area has got larger. Is larger in 2005 and in 1991. Okay, that's that question done. Moving on to question 11. Table shows the number of motorcycles in thousands registered each quarter from the first quarter of 2005 up to the first quarter of 2008. Okay, and that is shown in this table. Then we've got a plot showing all the information as a time series, and the 4-point moving averages have been plotted. So a 4-point moving average means that you take 4 numbers and you find their average, and then you take the next 4 numbers and you find their average. So let's look at the first 4 numbers, 1, 2, 3, 4. Remember, average, add up each one, divide by 4, and you're going to get that. And where do we plot it? We plot it bang in the middle of those 4 points. Okay, so that's it on the graph. How about on the table? We add up the first 4 numbers, 1, 2, 3, 4, divide by 4, and it should give you the value of 33.5. You can check it yourself if you're not sure, but that's been done by the examiner or whoever wrote the question paper for you. The only ones that we need to do are the last 2 moving averages. Okay, so we want to take the last 4 numbers and find the average. That's going to be our last 4-point moving average, and we want to take the last but 4 numbers. So we'll do the green ones first, and we're going to add up these 4 numbers and divide by 4. Okay, so on your calculator, add up the green numbers, 31.8 plus 44.2 plus 41.8 plus 28.6, and then divide it by 4 because there's 4 of them, and you get 36.6. Now don't forget that we're in thousands. Okay, so thousands. And the next one, adding up your yellow numbers now, 44.2 plus 41.8 plus 28.6 plus 31.4, 4-point moving average, 4 numbers divided by 4, 36.5. Okay, so there are your 2 answers, and they're thousands. So let's just write them in where they've got to go. 36.6, 36.5. And it's already written thousands for us. Okay, draw a trend line on the graph. Oh, don't forget, plot them on the graph as well first. Okay, before we move on. So, the last one, remember we highlighted in yellow, is for these 4 points. It's not yellow, 1 sec. For these last 4 points, 1, 2, 3, 4. So the average is going to go in the middle of those 4 points. So this is 2, 3, 4, and 1 again. Middle, you can see, is here. Okay, so whatever value, we are going to plot it in the middle there. And we're going to use red pen for that. Okay, so the last one, 36.5. Let's go up. 35, 36, 36.5 right there. And 36.6 is the other one. And the other one, I'll show you another trick you can do. If you look at your moving averages, they're all 1 apart. Okay, so if you can see that you go and jump another 1 to get into half of the next one, this is where it's going to have to go. Or you can do the method I showed you a second ago. And here we want 36.6 for So it's 36 up a bit. Okay, and like I said, if you go another one across, you'll get to where the next moving average should be. Now we need to draw a straight line with your ruler through these points. I'm going to do mine in a nice green to stand out. Okay, and it's got to be trend line through the middle of as many of these points as you can while still being straight. Okay, so that's pretty good, I'd say. For a trend line, you've drawn it on, and that's all part B wants us to do. Next part, describe and interpret the trend. So let's have a look back to it, see what's going on. Can you see it's going slightly up? Okay, so it's not going perfectly horizontal, it's going across and up, so it's slight positive correlation there. So we're going to write slight positive correlation. So as time increases, if we're talking about years, that's time, then the motorcycles registered is going up as well. So we'll explain that in words. Okay. So slight positive correlation or trend. And what that means is, as time increases, then the number of motorcycles registered also increases. Okay. Another write down question, so we should be able to just figure it out without any difficult calculations. Write down the quarter with the greatest number of motorcycles registered each year. So let's look at each year and see which quarter, 1, 2, 3 or 4 has the highest number each time. In 2005, this is the highest. 2006, this is the highest. 2007, this is the highest. So it's always quarter 2. Now I know there's no answer here, that's because we've not got the data yet for that one. Okay? So maybe that time hasn't happened yet. The answer is quarter 2. Work out the mean seasonal variation for quarter 2. Give your answer to the nearest whole number. Right, variation means how something is changing from what you would expect it to be or what it could be. Okay, so seasonal is just to do with the time of year, and if we've already split up our time of year into 4 quarters, then that's going to help us know what season we're on, and the season we're talking about is quarter 2. So what do we want to know about where it's varied from? We want to know about where it's varied from what we expected, which is a trend line. That shows us what we're expecting to see, this line does. Okay, so if we go to quarter 2 for this year, 2008, and we go up, we're going to have to extend our trend line. So you just get your ruler and carry the line on. Okay, and let's just see where we expect it to be. I'm just going to cheat with a dotted line here quickly. Okay, so this value you could read across your ruler is about 37. Okay, we'll call it 37. So we would have expected it, if it was on this trend line, to be 37. Now, what's it talking about variation? Well, it's saying that each time quarter 2 is not actually on the trend line. Look how far away it is each time. Okay. Now let's go back to the question. I'm actually answering 2 questions in one here because I've started talking about the next one as well. Okay. So these red lines, the distance from where we'd expect it to be on the trend line, let's count the squares here. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 away from where we expected it to be. This next one, 1, 2, 3, 4, 5, 6, 7 away from where we expected it to be. Next one, 1, 2, 3, 4, 5, 6, 7, 8 away from where we expected it to be. Okay, so the average of where we'd expect Q2 to be each time, how far away, is going to be the average of those 3 numbers, 10, 7, and 8. So we're going to do 10, add 7, add 8, divide by 3. Okay, so 10, add 7, add 8, divided by 3. And you can do that on your calculator. Do it now for you. 25 divided by 3, which your calculator will tell you is 8.3 reoccurring, which means that you've got 8.3333 going on forever. Okay, now remember that our numbers were in thousands, so this stands for 8,000, this bit stands for hundreds, tens, units in this case. Okay, so if we know that the 8 is 1,000, you can think that the 333 must be 333. It was asked for the nearest whole number, so that is your answer, 8,333. Part F. Use your answer to Part E to predict the number of motorcycles registered in quarter 2 of 2008. Okay, so our variance, our seasonal variation is 8.33 or 8,333, and that is how much on average, if we look at our graph, how high above the graph Q2 is going to be, 8.3. Okay, that's close, the 8. So this is going to be 8.333 above. Now remember, before we read this off we said it was 37, so we need to do 37 or 37,000 plus 833. Okay, so plus 1,000, and you get the answer of 45,333. For how many marks? 2 marks. 11 marks for the whole question. Question 12, we're given a table. The table gives information about the year-on-year percent increase in retail prices and the average mortgage rate. Okay, so looking at average mortgage rate and retail price index, basically, increase in retail prices. So, in the first week of July for each of 11 years, work out Spearman's rank correlation coefficient, or SRCC for short, for this data. You may use the blank columns in the table to help you with your calculations. That's a big clue that you're going to need these. Now, if you remember from the front of your formula book that you're given Spearman's rank correlation coefficient, and now would be a good time to write it down. So it's the last one here that we're going to want to use. Okay, so 1 minus 6 times the sum of d squared over n times n squared minus 1. And I'll explain what each part of the formula means now as well. So let's write it down. Okay, so SRCC 1 minus sum of d squared, and it's 6 times it, over n times n squared minus 1. Can remember that one right. Okay, so d is your difference, and we'll see how we get that in a minute. Difference. N is your number of piece of data. And that's all you need. Okay, so somehow we need to be able to find d, the difference. Well, difference in what? Well, what Spearman's rank does is it ranks things, as the word rank implies. Now, if you notice, this first column is already in order, so it's already ranked. And if we're ranking them from biggest to smallest, then this 8.7 would be number 1, wouldn't it? It would be first. 8 would be 2, 3, they're already in order, so it's like they're running a race or something. This is the positions. The bigger you are, the further in the race you are, your position. Okay, because it's retail prices, we'll call that capital R. Okay, we want to do the same thing for mortgages, but these ones are not in order for you. So what you have to do is look through and try and find the biggest one first, the winner of a race. So the biggest number I can see there is 7.27, so that comes first. Let's tick it off so we don't count it twice. Next biggest is going to be, I think, 5.83. Tick that off. If you tell you're doing it wrong by this tick off method, then you can always you know, just change it around. That's the advantage of this. Next one is going to be 5.7 down at the bottom. Next one is going to be 5.66, or no, 5.67, even closer. Then 5.66. Then we're going to have 5.17, or 7th biggest. Then we're going to have 4.58 down at the bottom. Then we're going to have 4.24, then 4.19, then 3.49. So that part was just literally numbering these in order. Biggest first. Because this one was biggest first, starting at 1, we had to do the same for the other, or your formula will not work properly. So let's call this M for mortgage. Okay, they've been put in order. They've been ranked. So let's call them little r for ranked. And to get the difference, you're going to do one, take away the other. As long as you do them in the same order all the way around, all the way down, it doesn't matter which way around. So 1 minus 3 is minus 2. You'll see the minuses don't actually matter in a minute. 2 minus 7 is minus 5. 3 minus 2 is 1. 4 minus 6 minus 2. 5 minus 10 minus 5. 6 minus 9 is minus 3. 7 minus 11 is minus 4. 8 minus 1 is 7. 9 minus 5 is 4. 10 minus 4 is 6. 11 minus 8 is 2. Now, the problem that you've got in Spearman's rank, when we just want to know about the differences, is some of these are negative. So if we just added up all these straight away, then the negatives and the positives would cancel each other out. We wouldn't get a very good result. So we don't do that. We do a clever maths trick, which says that you square the number, because all square numbers are positive. Even if you do a minus times a minus, you get a positive. So minus 2 times minus 2 is just the same as 2 times 2. Okay, they both give you 4. So for that reason, I'm not even going to say minuses. I'm just going to say 2 times 2, 4, 5 times 5, 25, 1 times 1 is 1, 2 times 2 is 4, 5 times 5 is 25, 3 times 3 is 9, 4 times 4 is 16, 7 times 7 is 49, 4 times 4 is 16, 6 times 6 is 36, 2 times 2 is 4. Okay? However, I've just realised that 11 minus 8 is not 2. 11 minus 8 is 3. So that should in fact be 9. I'll just have a quick glance through. I think all the rest are cool. Okay, one silly little mistake. I'm sure you were shouting at your screen. Now what we want to do is we want to add up these numbers, because look in our formula. It says add up the d squared numbers, the difference is squared. Let's add up all those highlighted ones on our calculator. So 4 plus 25 plus 1 plus 4 plus 25 plus 9 plus 16 plus 49 plus 16 plus 36 plus 9. That gives you 194. Okay, so you know that your sum of d squared is 194. So we know this little part of the formula, the highlighted bit. N, well, how many numbers have we got? How many data pieces? Well, you could count them. 10, 11, or you could think, it says 11 there, whichever you rather. Okay, so we're going to use our formula, and I'll do this in the best way that I know how to substitute into formula by doing it on this software. Is I'm going to erase the bits as we substitute in. Okay, so the sum of d squared, we just spoke about knowing what that is. So that is going to be 194. And because it was just next to it, there was an invisible times, just like there's an invisible times here. N, we've just said, is 11, so we're going to change these to 11. Okay. And now we can type this into our calculator. So, you can make it look just like that on your calculator by using this fraction button for the second part. 1 minus 6 times 194 divided by 11 times 11 squared, which is 121 if you just want to type that in. Take 1 and you get 0.118 with the 1 and the 8 repeating forever. However, you can just leave it as 0.118. 3 decimal places is 5. Okay, 3 marks. Interpret your answer to part A. Well, let me tell you about Spearman's rank. What Spearman's rank does is it gives you a number between -1 and 1, okay, with 0 being in the middle. If your number is close to -1 or -1, it means that your values are ranked the other way round. Okay, so a big one might correspond to a small one. If it's close to 0, there's no correlation between the two. And if it's close to 1, there's positive correlation, which means the bigger ones tie up with the bigger ones and the smaller ones tie up with the smaller ones. In our case, we've got quite a small positive number. So we could say that there is slight positive correlation or you could say close to no correlation. I'm going to go with slight positive correlation. Okay, so what does that mean? So it means as the average mortgage rate increases, so do the average retail prices, or just the increase in the retail prices, retail price index. Okay, so let's just write that in our explanation. Slight positive correlation as the mortgage rate increases. So do the retail prices. Okay, moving on then. Question 13. The table gives information about the lengths of reigns in years of the English kings and queens since the year 1014. So we're using L to mean the length in years. So the first time we've got the length being between 0 and 5, that's our first category, and we've got 12 kings and queens that go into that category. So the frequency is how many, or 12 is how many between 0 and 5. So to interpret that, there are 12 kings and queens since 1014 that reigned between 0 and 5 years. We don't know whereabouts unless you look into your history books, but we know there's 12 of them in this category. Okay, and you can see a histogram below that says from 0 to 5. 5 is in the middle of 0 and 10 here. So from 0 to 5 we go up to a certain amount, which we'll talk about in a minute, and this area in the middle represents 12 people. Okay, the next one between 5 and 15 represents the number of people between 5 and 15, which is 11. Okay, so 11 people represented by this area. The next one, I'll do this in a different colour to make it really stand out. Between 15 and 25 we had 12 again. So the next bar area is 12. That should be a bit clearer for you. Okay, and again between 20 and 30 is 25, halfway bang in between. Okay, now the other categories that we've got are going to be going from 25 to 45. Look, so our next bar is going to be going from 25, I'll do it in blue, the bits we're going to add in, to 45, but we don't yet know how high up the bar is going to go. We just know the width. And the next one is going to go from 45 to 65, 45 to 65. Again, we just know the width at the minute. I've done a whole video on histograms if you aren't sure about them and want to check that out to help you with this question as well. Okay, so when you're looking at these bars, it's not the same as a bar chart, because on a bar chart you look how high it is and that's your frequency, that's how many. Here we're saying the area is the frequency. Okay, remember here I said 12, that's because the area represents 12. Now the side is the width. How do you get the area of a rectangle? Well, you do the base times the height. And what we call the height, instead of frequency, is FD for frequency density. So for a rectangle, it's going to be the width times by the frequency density, and that gives us a frequency. Okay, so remember that. And when we had our first bar, we know our frequency was 12, so we want to think about what our class width is, or just width. So we want to make a whole new row for that. So the width, if you're going from 0 to 5, is 5. The width, if you're going from 5 to 15 on your bar, is 10. The width, if you're going from 15 to 25, is 10. Just do 25 minus 15. The width from 25 to 45 is 20, and the width from 45 to 65 is 20. Okay, now if you have frequency density here, if you, from our formula that we spoke about, times something here by 5, you get 12. As represented by this diagram, where we know that it is 5 wide, and we just want to know how high it is. So it's a little bit of math skills needed here to think, well, if I'm timesing something to get 12, I want to do the opposite, and I want to get question mark 12 divided by 5, which is equivalent to rearranging this formula to get that frequency density equals frequency divided by width. So 12 divided by 5 is going to give you the missing length of 2.4. Okay, so let's add all these into our new column. Now this 2.4 is going to be really helpful to help us crack the code, because we know that this is now 2.4. And from 2.4 to 2.5 is two little squares, which means each square has to be 0.05, so that in the middle here we've got halfway in between. Okay, so let's just put a scale over here. That is 0.05, just to remember. Okay, that's going to help us complete the incomplete histogram. Okay, next one is going to be something here times 10 to give you 11. Well, it's going to be 1.1. You can get that by doing 11 divided by 10. Here, 1.2. Next one I'm going to do on the calculator, which is going to be 8 divided by 20 to give you 0.4. You could divide by 2 and then divide by 10. So 4 divided by 20 is going to give you 0.2. Okay, so this is how high up each one of your bars has to go. Okay, so let's just check. Does this one go up to 1.1 as we predict? Looks like it, doesn't it? The next one up to 1.2 looks like it. So we just need to finish off our own two bars. We already said how wide they were going to be. We just need to make the first one go up to 0.4. And remember that we've already spoken about each little dot being 0.05, but what's more useful is two squares and 0.01, and we want to go up 0.04, so it's 4 of those for the first one. Okay, so 1, 2, 3, 4. Let's draw nice and neat. You definitely want your ruler here. Square. Can even do a bit of shading. Okay, first one done. Next one, let's do it in a different colour. Let's see how high up we decided it was going to go. Decided it was only going to go at 0.2, which is 4 little squares, or half of what you just did. So it's going to go up to there. Okay, and you can shade that one in as well. So we've completed the histogram, the 3 marks. Part B, estimate how many English kings and queens reigned from between 20 and 50 years. Good question. Okay, so on our bar chart, remember the reigning years is along the bottom axis. We want to know between 20, which is here, and 50, which is here. I know it doesn't go up that high, but I just want you to see that we're only looking in this area here. So what the question's basically saying is add up this area, and this little area here. Now what I want to do before we carry on with that is I want to label, like we labelled here, here and here, how many each of the rectangles stand for. and what they stand for is the frequency. So the two new ones we drew in stand for 8 and 4. Okay, so this is 8 and this is 4. Well, look at this. Can you see? We can use our head a bit and think this 4 is made up of 4 of those rectangles. And they're the same size, so that means that this little bit here must be 1. Can you see this rectangle that was 12 is split bang down the middle? So that means the bit that we're interested in is 6. So to get the total of this, this and this, we're just going to do 6, add 8, add 1, which is going to be 15. Okay, so 15 is our answer, and I think the simpler you can keep this the better, because that's 3 marks for just using your diagram and using your head to see how things were split up. Okay, so quite a cool question. Moving on, question 14. I love a good probability question. The probability of a person having an allergy to a particular nut is 0.1. Okay, so probability of an allergy, let's write that in math speak, because mathematicians don't like writing too much down. Probability of allergy equals 0.1. Okay, 1 in 10 people have it. A test is available to see if someone has the allergy. That's good. However, the test isn't perfect. I know that because in 80% of the cases it gives a positive result. Now if it was perfect, it would give everyone a positive result who actually had the allergy. But there's some people who get missed out on the diagnosis here. If a patient does not have this allergy, there's a 0.5 probability of getting a positive result. So that means that you've gone to have a test, and it's meant to test if you've got an allergy. You don't have the allergy, but it tells you it does. It tells you that you do, which isn't very good. Okay, but it happens sometimes. Complete the tree diagram for the 2 events. Okay, so if there's a 0.1% chance that you have the allergy, well, you either have it or you don't. So the 2 probabilities have got to add up to 1. That's 0.9. Your test can either be positive or negative. 0.8 positive, it's got to add up to 1, 0.2 negative therefore. Okay, let's read the question to get some extra information. If the patient does not have the allergy, 0.5% of getting a positive result, so this is going to be 0.05, not 0.5. And you can either be positive or negative again, so the others have to add up to 1, these 2, only 2 possibilities. Now, to get these numbers the probability at the end, you multiply along the branches. Okay, and they've already done the first one for you. 0.1 times 0.8 is 0.08. Next one we're going to have to do ourselves, so we're going along 0.1, 0.2, so it's going to be 0.02 is your answer. If you multiply, do it in your head or on the calculator. 0.02. Okay, the next one is 0.9 times 0.05. You can do on your calculator and get 0.045. The final one, 0.9 times 0.95, and that gives you 0.855. Now all possible probabilities should add up to 1. So if you actually add down here as a check on your calculator, they should sum to 1. Okay. Muller takes a test and gets a positive result. So all we know about Muller is that he's either here on the tree diagram or he's here. Okay. He's got a positive result, but we don't yet know if he has the allergy or doesn't have it, because the test can have a false positive. Work out the probability that Mullah has the allergy. Okay, so what's the probability that he's here and not here? Well, we do not care about negatives, so we can cross this out straight away. Don't cross your actual answer out in the exam, I'm just making a point here. Okay, the only ones that we care about are this probability and this probability. Okay, so what do all the total possibilities add up to? Well, it's 0.08 plus 0.045. They're the only possibilities, so that's going to go on the bottom. Okay, and we want to know about this out of both of them. So 0.08 over them both added together. So if you type that into your calculator, and you can get it to look like that again with the fraction button, 0.08 over, make sure it's all on the bottom row, 0.08 plus 0.045, that should give you 0.64, which is your answer for the probability. Next part, part C. 5 people are selected at random. X is the number of these people who have the allergy. So imagine you've got 1, 2, 3, 4, 5, okay, and some of them have got the allergy. We don't know how many. Could be 1, could be 2, could be 3, could be 4, could be 5. Let's call that number X. What is the name of a probability distribution? Now they either have the allergy or not. Okay, yes or no. So that's 2 options, and the word bi for 2 should give you a clue. It's binomial. Okay, so as we just said, when it asks for properties needed in this context, distribution to be a suitable model for X. Okay, properties needed is that there's only 2 options. Binomial. And there's a couple more options. There's a couple more properties needed as well, such that there has to be a set number of trials. And what I mean by trials is how many people we're testing. Okay, so we can put in brackets 5 people. Okay, and also the probabilities sum to 1. And the probabilities do not change. They are fixed. Okay. We get as the 3 marks. Work out the probability that out of these 5 people that we talked about there, 1, 2, 3, 4, 5 people, there will be exactly 3 people who have the allergy. Okay, so it could be any of these 3. Now, there's this thing in maths called permutations, which means that it could be those 3 that we just put crosses on. It could be these 3, or it could be these 3, okay, or any combination. Now what you might want to do is you might want to count all the possible ways, but that might take you a while. Advanced mathematicians actually have a button on their calculator that can work this out for them. If you tell them you've got 5 things and you want to know how many ways around you can organise 3, or your examiner might be really nice and tell you in a formula. Okay, now in this formula, P stands for the probability of the allergy, okay, so the event happening. And remember we wrote down in the last question the probability of the allergy happening. was 0.1. Now we just spoke about the two probabilities adding up to 1 because there's only two possibilities. Q adds up with 0.1 to give you 1 because they're the only two options. So Q is 0.0, 0.9. Okay? Now, you have P every time you have an allergy, one person with an allergy. So if you have P to the power of 3, like we do here, that means you've got 3 people with the allergy. So the part of this formula that we want, and I'm not going to explain fully about this formula because you don't need to know until A level, you just need to be able to use it here. This stands for 3 people for P, 2 people for Q. And the number in front is what I just hinted at, which is the number of different ways that this can happen. So you need this whole formula part. 10 P cubed Q squared. So it's 10 times by 0.1 for the first person having the allergy, and then cubed for 3 people, and 0.9 is Q for 1 person not having the allergy, and squared for 2 people. Type this into your calculator. 10 times 0.1 cubed times 0.9 squared, and you're going to get 8.1 times 10 to the minus 3, or 0.0001231. Okay, and that is your final answer. How many marks was that one? 3 marks. This is more A level, so well done if you've followed this one. Okay, moving on to the last question, question 15. The time series shows the percent of people aged 16 and over who smoked in the years 1998 to 2007. So you can see 1998 here where we have our first data points, up to 2007 here with our other 2 data points. And we've got a nice key to explain that the diamonds, the top row means for men, so let's do that in a nice green colour. And the bottom row, the squares, is for women, and let's do that in a pink colour. Okay, 2 different trends, men and women. So now we've seen what's what, let's just get that back to how it was. In 1998, the government published a leaflet, Smoking Kills. This had a target of cutting the percentage of people of 16 and over smoking to 24% by 2010. Now our graph doesn't even go up to 2010, we'd have to carry it on to 2009, then 2010. So we don't actually know what's going to happen here, which is quite important. In theory, it could go back up, but the trend line looks like it might be carrying on going down. But you can never predict the future perfectly. Mathematicians might try, but we're not fortune tellers. Okay, so part A. From the graph, what conclusion can be made about the success of the leaflet? Now I'm going to have to get my GCSE head on here, because in A-level statistics you would be giving a slightly different answer to this. Okay, but in terms of GCSE, what it's trying to get at is, have we met this target? Have we gone below 24%? And we have to give our reasons. Okay, so here's 25%, so here's 24%. Let's put a dotted line across. And can you see, there the women have crossed it, there the men have crossed it. So already we are below the 24% line, so you would hope that in 2010 you've met your target as well. Okay, so we're going to explain that, and we're also going to explain that as long as it doesn't rise up, that's going to be fine. So, target has been met already. And will be met in 2010 as long as it doesn't rise up again. Rise above 24% again for men or women. Okay, and that will get you the 2 marks for that question. Part B. Compare the 2 time series graphs. So whenever you have a comparison to make, look how many marks it's for, and that is how many points at least you need to make. So, remember when I put the highlighter on, this line is always lower than the other line. And this lower line is for women. So in every year from 1998 to 2007, the percent of women smoking is less than the percent of men smoking. So let's write that down. Percent of women smoking is always below percent of men smoking. And if you really wanted to, you could put between 1998 and 2008, which we talked about, the dates, 2007. But that would be fine for GCSE. The other thing that we can notice is actually the women doesn't seem to have dropped down as far from where it started to where it finished. Whereas the men started up on 30 and they've gone right the way down to 22 here. So they've dropped by 8. So you could talk about that and you could find out how much the women have dropped by and compare. I'm going to look at this distance here. Okay, can you see the gap between the men and women there is this much as highlighted? And then the gap between men and women there is decreased. Okay, so that can be our second and final point. The difference between percent of men smoking and women smoking has decreased. 1 point in blue, 1 point in green. That finalises our paper. Out of 100 marks, hopefully we've got full marks, but that is the first GCSE statistics video that I've done. Hope you enjoyed it, I hope it made sense and has helped you, and see you in the next video. Good luck with achieving maths. Goodbye.